Before we start, I'd just like to clarify, we're rolling out Riemann at Beamly right now. It's not in production, unlike what the blurb said. So this is definitely work in progress for us. And this is not something that we have like absolute knowledge of. So, right. So normally, when teams are trying to figure out what their platform looks like or how their platform is behaving, they have usually two tools. They look at dashboards, and those have graphs on them usually, and they have averages, etc. And then they have alerts, and alerts are triggered by, next slide please. And alerts are triggered by basically a whole bunch of events that might relate to CPU usage that's too high, memory usage that's too high. The problem is that you end up with dashboards that are you have too many dashboards, and they're really, really good at giving you information after the fact, after you've got all the data recorded and persisted somewhere, but they're not very good at giving you any information about when something is going to happen, or if you're a team with a reasonably large platform, you end up with too many dashboards. It's very difficult to get that one visualization that will display absolutely everything you need to know about your platform. So the next thing, so basically alerting usually people will kick off with single metrics or when a service is down, but it's very difficult to figure out interrelated effect, things like if a CPU on a server is high and network I/O on the database is high, how do I actually crystallize that into a single alert? That's a little bit difficult to do. There are various strategies that people have taken for it, and well, I'm going to talk about one of them. So we were thinking about how we could accomplish things like that, how we could figure out where if CPU load on one of our services was really high and we were getting multiple instances spun up because we're auto-scaled, how would we detect a particular situation where it ends up actually spiking load in a database, and how could we create a single alert from that? So we took a look at Riemann, and that allowed us to basically deal with all the metrics that we collect and all the events that we trigger. So next slide, please. It's available at Riemann.io. Kyle Kingsbury, the guy who started the project, he's really, really clever. There's stuff that he blogs about usually that's very handy. If you're doing ops work, he does a lot of work on distributed services. Just a really, really clever guy and really high quality of work. So took a look at Riemann and went from there. Okay, so this is directly off their webpage, and it's actually a pretty good explanation of what it does. It's, the dash in the middle is kind of peripheral. It's actually not the best part of Riemann. It will actually grab a whole bunch of information from your platform, a lot, and it's fairly flexible in the format that you can send to it. And you can basically manipulate that data and send it forward. Okay, right. Okay, I know a lot of people cringe when they hear Java. It's not hard. It's really, really quite simple to deploy. It's a single fat jar and some config, and you're done. So Riemann effectively has 4 concepts. Everything that is fed into it is an event, and the source of all events are streams. It does allow you to persist data or persist events in an index, and it allows you to actually change things around and send them to different streams. All you have to do is write small functions that manipulate data. It's not a terribly large amount of work. So, right. That's what an event looks like. And going from something like, how many people here use graphite? So going from a carbon event Does that look a little bit richer? Is there more context to an event? David mentioned things like Metrics 2.0. Does that look a little 2.0? I think it does. So it's just, pick a language, and it looks like some sort of hash table in your language. So next slide, please. All right, and that's a stream. Again, this is directly off their page. So all the E's on that illustration are events. They get stuck in, and then there are filters that are working on those. That where is a filter. It's dumping events that don't satisfy that condition, and it's generating an email once that condition is satisfied. Right, okay. There's going to be a few brackets in the code that I show, unfortunately. If you don't like them, just eventually you won't see brackets. Lotia has a lot of brackets, it's a Lisp, but these are fairly terse lines of code. You don't have to write tons and tons of config. The problem there is that you can manipulate events however you'd like, and you have the full power of a programming language, and so you can tie yourself up in knots, or you can overthink things, or any of that. But if you've ever had a situation where you've dealt with a piece of software that says, if only it could do this, if only this little bit was there, and you send an email in the mailing list or whatever, well, you don't have to. You can just write the code, and it generally works. The other really nice thing about it is, because it's a monitoring system, and well, an event processing system that happens to monitor things, you don't actually have to, turn it off or redeploy. You can actually send it new config, send it, like most daemons, you can actually do the equivalent of a sig hop, and it works really well. All right, so at Beamly, we have, the way we've rolled out Riemann is all of our servers are sending metrics to our Sensu instance, and what we're doing is we're sending stuff to our Graphite server. The metrics are being persisted, and we're also sending a single copy of every metric to Riemann. That way we don't actually have to worry about any of the metrics getting modified or adulterated. We're working with the same metric data that Graphite sees. The advantage is that we can do things like ask questions of the stream that's coming through to Riemann. Right, and the trick we have here is, I showed you the beginning of the talk, I showed you what an event looks like. Well, all we have are carbon events. They're fairly sparse, and the nice thing that Riemann offers is you can fire up a Graphite server, and it will accept just standard Graphite metrics. You don't have to do any additional work to get it to get it going. There's no other format that's required. So we have a trick so what we're doing here is we're just transforming those into Riemann events. Again, fairly small amount of code. I haven't mentioned a couple of functions that we've written, but those are two-line functions, and I'm happy to share the code with anyone who'd like. All we're doing here is we're taking the event path that Graphite has. That's how it'll identify things, and we're basically trying to extract information out of it. So, what we're doing is we're transforming a single carbon event into something that more closely resembles a Riemann event. Next slide. All right, and so what we have here is, once we have a stream coming in, we've transformed it into Graphite events. Into Riemann events, and then we are basically trying to grab select events where we have all the data that's coming in. We're going to, be able to. We're now able to ask questions of it, and filter things fairly simply. I mean, this reads quite clearly, and what we're trying to figure out is if with the type of servers that we're working with that we've specified, if any of them happen to be swapping, we can then actually store swapping state in the index and do things from it. Right. Riemann comes with a lot of functionality to send stuff to other services. So once you've fully processed a set of streams, you can do things with it. You can actually, generate an email off it. You can generate a PagerDuty off it. You can, you can basically store the manipulated events in a database of choice, and they're always coming up with new ways to persist your events. And you can also write your own plugin because that can be part of your config. You can include other files and libraries. Right. There is the Riemann Dashboard. The challenge is, again, you end up with very, very dense dashboards, and when you have to deal with a very large number of components, the amount of information presented is eventually doesn't remain particularly useful. So we've struggled with using the dashboard. Next slide, please. Great. What we have here is the problems we faced with Riemann. It is stateful because you have this index. You have challenges with trying to keep a lot of information in the Riemann index. If that instance crashes, you lose a whole bunch of data that have you indexed. There's no redundancy because it's storing all this information in memory. You can have multiple Riemann instances, but you can't actually do things like have a master Riemann instance that can have backups. The way to achieve that is you actually have to have sort of cascading filters in Riemann, and you can reduce load in your Riemann instances that way. The other problem is that the documentation for the dashboard is not very good. Trying to query a dashboard actually required that I read the Riemann dashboard source, which wasn't particularly fun. I also had to read some of the Riemann index source. That requires documentation. However, it's quite powerful and it's quite useful to deal with a conglomeration of alerts and deal with having to make sense of metrics data that goes beyond a single service type. So I'd encourage you to take a look at it. Right, and so here are the resources that I've used before. There's the IRC channel, which actually Kyle hangs out on and is very quick to respond on. There's the website has decent documentation and stuff that doesn't actually concern the Riemann dashboard. Actually, the funny thing about the Riemann dashboard is that on the GitHub site, Kyle has said that he's not a front-end developer and he would love input. So if anybody likes to do any front-end work, feel free to send input his way. And The Guardian actually is using Riemann in production, so they're a pretty handy resource. That's me. It's a fairly short talk after pizza.